Good morning, students. I believe you are set for mathematics class this morning. Your writing materials, your jotter, pen, paper, textbook, and your 4-figure table must be beside you. My name is Ilesomi Tokwe Joseph. I received your assignment. That was on Monday, the class that was held on Monday. It was so fantastic. You guys are doing a great and wonderful job. Keep it up, and I'm expecting more from you. Challenges from you, give me questions, ask questions. So we're going to continue from where we stopped, which is trigonometry. And today will be the concluding part of this class. Now let's have the correction to the exercises that was given in the last class. You have to find the angles whose sines are and cosines are 0.5878, 0.4067, 7/9, 3/8. And the last question, you have to find the long side of the square with the diagonal 20 centimeter long. Okay, let's start with the first question. Now, the first thing you do, first thing first, I'm starting with A, which is sine. Okay, now the first thing you are going to do is let me use B the angle. So that means sine B is 0.5878. So when you check your table, go to your sine table, check where can you get 0.5878, and that will be under 36. That is 36 under 0. That is for sine. Then for cosine, we have for cosine, that will be cos B equals 0.5878. So when you do the dot of cosine, you will see it under 54. Now, let me give you a clue. Once you are able to get for sine, sine here is 36 degrees. The next one, since we are dealing with a right angle triangle, it can't exceed 90. So it's between 0 and 90. So just subtract 36 from 90 will give you 54. I think the stress has been cut off now. So people are like, okay, as simple as that. Now, let's pick the other one. This is question 2A. Let the angle be C. That will give us 0.4067. So, what is that angle? That is, where can you find 0.4067? It is 24 under 0, which is 24 degrees. So, the cosine will be what? Will just be 90 minus 24. And 90 minus 24 will give us 66 degrees. Now, the next one is 7/9. 7/9. I have 3A. So that means let the angle be A. That means sine A is 7/9. When you punch your calculator, 7/9 is 0.7778. So what is that angle that will give us 0.778? Now, you will check. When you check, you will see it. You will not see 0.778 exactly, but you see what is closer, which is 0.771, and it is under 51. 51 degrees. Now, when you subtract 0.771 and 0.778, what are you going to have? 7. So you now go and check the difference of 7, and when you trace it under 6 in the difference table. that will be plus 0.06 degrees, and that will give you 51.06 degrees. Now, to get for your cosine, will just be 90 degree minus 51.06. So that means A for cosine, 90 degree minus 51.06, and that will give me 38.94. 38.94 degrees. Now, the other one is 3/8. Okay, the other one is 3/8. Oh, how am I going to do that? There's no space here any longer. Let me do it. Okay, just permit me to do it here. This is question 4a. So, the sign of, I'm using D now. 3/8 is 0.375. And if I found it, I'm going to see 0.3746, not 0.3750. To be 0.3746, and that is 21. It is under 21 degrees. Then plus, when you subtract 0.375 and 0.3746, what are you having left? You're having 4. So, but we can't locate 4 under the difference table, but we are able to locate 3 and 5. In between 3 and 5, we have 4. So, the rule is that you pick the highest, which is 5. And 5 is located under 3. That will be plus 0.03. And D will be 22.03 degrees. Now, to get for your cosine, just subtract 90 minus 22.03, and that will give you 67.97. That will be for your cosine. So, now let's look at the concluding part of this exercise. This is a square. And this is the diagonal of the square. A square has all its sides equal. Now, if you are looking for this side, which is the diagonal, I call it D. Use Pythagoras theorem. D square equals what? L square plus L square. And that means D equals the square root of 2L square. So since we are given that our D, which is the diagonal, is 20 centimeters, that will be 20 equals the square root of 2L square. Are you following? So I've taught you change of subbit of the formula. You square both sides. That is the next thing. You square both sides. Square both sides. So 20 square will give you what? 400. So since you are squaring both sides, the square root will go. You have 2L square. So divide both sides by 2. You have L square equals 200. And L will be the square root of 200. And that will give you 14.14 centimeters. Now, to the nearest whole number, that will give you 14 centimeters. To the nearest whole number will give you 14 centimeters. Sorry. So, to the nearest whole number, L equals 14. L equals 14.14 centimeters. So to the nearest whole number, that will be 14 centimeters. You see? Now, today, what do we have for today? We are going to use 4-figure tables. This will just be a recap, but we are to solve practical problems using the sines and cosine, and we are to solve right angle triangles using Pythagoras rule and the 3 trigonometrical ratios. Okay, let's start with the application. How do we apply this? We apply it by finding the angle and the length and you are going to see with the example how we apply sine and cosine of angles. Now, example 1. Example 1 is saying that a wire 12 meters long goes from the top of a 6-meter pole. This is the pole. This is your pole. This pole is 6 meters. Then the wire goes like this. Then this is not the complete, this is something like this. Like this. Then this is the ground level. Okay. Now, we were told that the wire is 12 meters. Then to a vertical point with a wall of 10 meters above the ground. 10 meters above the ground. This is the wall. Here is the wall. And this wall is 10 meters above the ground. This is the ground. This is the ground. Now, what is the angle between the wall and the wire? This is the wire. This is the wire. Then this is the wall. So you are looking for the angle here, theta. Don't forget this will be at right angle here. So that means that from here to here will be 6. And since the whole length is 10, so that means from here to here will be 4. So that means the whole length is 10. So that is complete. Now, having drawn the diagram, what is our theta? So I can bring out the diagram. This is what you have. We have theta here. We have this to be 4. We have this to be 12. Okay. Now, you are looking for theta. Where the angle is facing will be your opposite side. You have the adjacent side and you have the hypotenuse side. So what will you use? You are going to use cos theta. Cos theta. That is cos theta equals adjacent side, which is 4, over hypotenuse, which is 12. So that means cos theta equals 1 over 3. So theta will be what? So you now go and check your 4-figure table. Either your 4-figure table or you can use, I would say you should use your 4-figure table. So 1 over 3 is the same thing as 0.3333. So you will see it under 70.53. I told you how you are going to do that. You trace, but when we trace, we were unable to get it. Like we did not get 0.33333, but we got something that is closer. Then we now subtracted, and we have this. I've taught you how to do that. Now the next question is we have to calculate the length of the hypotenuse of the triangle below. This is the triangle. This is the triangle. The angle is 40. I have 43 here. We have H here, and I have 8 centimeters. If I'm not mistaken. Okay. Now, where the angle is facing, that is opposite. That means 8 centimeters is the opposite, and we are looking for H. This is at right angle triangle. So, what are you going to use? We're going to use sine 43 equals opposite, which is 8, over hypotenuse, which is H. So when you cross multiply, follow me to the next page. We are going to have sine 43 multiplied by H equals 8. So what you're looking for is H. So divide both sides by what? Sine 43. And once you do this, that will be 8 divided by sine 43. 8 divided by sine 43. That will be 11.73. 11.73 centimeters. This is to 2 decimal places. Now, another question is, A car travels 120 meters along a straight road which is inclined at 8 degrees. Okay, now let's look at the diagram. This is the road. Then the car inclined is as if it's climbing a hill. Okay, then we have something like this. This is at right angle. The angle is at 8 to the horizontal. Then the car is 120 meters long. Then we are looking for H. Don't forget, where the angle is facing is the opposite side, and we have the hypotenuse side. Okay, so what are we going to use there? We are going to use sine 8 degrees equals opposite H over hypotenuse 120 meters. So you cross multiply, that means H equals sine 8 degrees multiplied by 120 meters. And you are going to have sine 8 multiplied by 120. That will give us 16.70 meters. Now, if the question states that correct to the nearest whole number, this will be 17. If the question says to two significant figures, that will also be 17. If the question says to two decimal places, it will be 16.70. So the question might come, it can be to one decimal place, that will be 16.7. So, but this is to two decimal places. Now, having understood that, let's go to another thing. Solving right-angled triangles. Solving right-angled triangles. Solving right-angled triangles. The ones that we just did now is practical application of sine and cosine. The practical application of sine and cosine. Now, the next thing that we want to talk about is solving right-angled triangles. How do you solve a right-angled triangles? Which method do you use? We use the Pythagoras rule and we use the trigonometrical ratios. And the trigonometrical ratios involve the sine of the angle, which will give us the hypotenuse, then the opposite, which is opposite over hypotenuse, and so on like that. Okay, now let's look at this diagram. I'm going to draw the diagram now. Diagram below. Look at it. It's a right angle triangle. If I'm saying right angle is at right angle, that is 90 here. Then this is A, I have C, and I have B. So this side will be B, because that's where the angle is facing. This side will be A, then this side will be C. Do you see me? I think there should be a difference between that C. This is too big. This is just small c. Okay? Now, in the figure, triangle ABC is any right angled at C. What is the meaning of that? That is, the angle is on C. That is the meaning of at C. That is, the angle is on C. And if you can see, this is the right angle on C. This is an angle on A. If there's an angle here, you say it is on A. If there's an angle here, if you say it's on B. Now, we have the following from Pythagoras. If you look at it very well, C is the hypotenuse side, A is the opposite side, and B is the adjacent side. So we have that C squared equals A squared plus B squared. That is from Pythagoras. Then from trigonometrical ratios, we have that sine A. If you're looking at A now, that is this A here. So sine A will be what? Opposite over hypotenuse, which is A over C. And that's what we have. Then sine B, if you're looking at B, from this B part, that will be B over C, because the distance will change. This is where the angle is. So this will be the opposite. So anywhere the angle is facing will be the opposite. Then we have cos A cos A, that will be opposite adjacent over hypotenuse, that is B over C, and so on like that, and so on like that. We have cos B, A over C, tan A over B, tan B, B over A. Now, let's look at this this particular problem that I have here. I have this diagram. Okay, I have this diagram. Checking maybe the space. Don't mind my drawing, please. And I have it here. This is at right angle. I have A, C, then I have here to be 10, here to be 13, here to be 7, and I have angles here. I call this angle small a, and small b. Then I have B here. So this is what we have. Now, the question says find A and B. The A and B that we are looking for there is the angle. This one is B, not A. It is the angle. It is the angle. Am I saying B? It's supposed to be P. Anyhow, it's just letters. It's just letters. Just know the position where it is. It is P because I'm checking this now. Okay. So now let's take. We are going to split the triangle. We are going to split the triangle. We are going to split the triangle, and it will be of this form like this. To be at right angle here. We have angle A, we have P. Let's say this one is D, A, this is 10, and this is 7. So this is angle A. Angle A. This is 7. Then we have the other one to be like this. This is angle B. This is 7. And this is 13. So let's say this one is P also, and let's say this one is D, and this is C. So I'll be referring to this diagram. Now, let's start with the first one. I'm picking this now for the first, to calculate A. I'm picking this. Okay? So we have where the angle is facing. Okay, that is, so 10 will be your opposite side, and 7 will be your adjacent side. So we have opposite and adjacent. What are we going to use there? Tan. That is tan of A, I mean the small a, which is the angle, equals opposite, which is 10, over adjacent, which is 7. 10 over 7 will give us 1.4286. 1.4286. Now you now go and check your turntable. Where do you have this? So that will be 1.4286. So it's under 55 degrees. That is for that. Now the next one, we are finding B. So where the angle is facing is the what? Is the opposite. Then we have the adjacent side. So we are also using tan. That is tan B. Tan B equals opposite, which is 13 over 7. 13 over 7. And that is 13 over 7 should give us 1 point, that is tan B equals 1.8571. So you now go and check your turntable. Where can you see that? That will be 1.8571. And that is 61.70. 61.70 degrees. Now, this is for A and B, that is those angles, A and B. Now, if you are now finding the size of APC, which is on angle P, so since P, you have P here, you have P here, so that means you are adding the two sides. You are adding the two angles, which is APC equals 55 degrees plus 61.70, and which will give us 55 plus 61.70. That will give us 116.70 degrees. So that will be the size of APC. APC. So, in conclusion, in the course of this lesson, I know we've dealt with how to use tables to find the values of angles, both for cosine, sine, even for tangent also, the same thing also applicable. So also to find angles, yes. And we also look into practical problems on trigonometry, and we discussed the last part on solving right angle triangles using Pythagoras rule and the trigonometrical ratios. So we've come to the end of today's class, and I will refer you to your textbook. I'm using New General Mathematics. Open to page 148. Yes, page 148. I will not be able to draw the diagram. So you just answer exercise. The question is on exercise 15E. 15E, question 1. You answer question 1, and you, not all, you just find the first two. The first two where you have A, B, C, and D, which is the unknown side. That's what you solve. Then for question 2, the same page, the same exercise, you go to question 2, you solve where you have those unknown. You have theta. Where do we have theta there? There's no theta there. Just ignore. Just check for the one that you have alpha and beta. Just check for the sign. You know, the one that is having 0.9 meters, then 3 meters, 7 meters, then 5 meters. So just do that one. Find alpha and beta. This is alpha. This is alpha, and this is beta. Please ignore this. So just solve it. Find it for me, and we are going to see to that in the next class before we go to the new topic. So I believe you enjoy today's class. Thank you very much. Do well to communicate with me, and for further readings, the textbooks and the link will be of greater advantage. Thank you very much. Enjoy yourself and stay blessed. Bye for now.